Process optimization has never been easier through the collaboration efforts between JSW, iMFLUX, and Moldex 3D. This study focuses on a 4-cavity dose cup layout, which features a hot runner manifold and a conformal cooling layout. JSW is a leading manufacturer of injection molding machines, known for their large size and electric servo drive technology. These machines can be selected for use in Moldex 3D simulation, and the machine process inputs can be translated directly into the machine interface. The iMFLUX technology modifies the injection molding process via closed-loop feedback that keeps low constant pressure and works on different machines, molds, or materials. By forcing an early switchover, Moldex 3D can enable an early pressure-controlled scenario. The iMFLUX system is comprised of software, nozzle, pressure sensor, and user interface. And pressure control used is then the maximum injection pressure of the machine. Using pressure control typically ends up in a short shot, so finding the minimum pressure required to fill the part completely will optimize the outputs from this molding technique. Using Moldex 3D simulation, this can all be done in a virtual DOE, rather than using valuable mold resources to conduct a formal mold trial. The iMFLUX typically requires a lower maximum pressure to fill the part, and therefore this molding can be done on smaller machines, lowering production costs. The pressure is also more evenly distributed because the packing is carried out as the material flows. This makes the pressure more uniform in the final molded part. This lower average density reduces part weight and material costs. In addition, a uniformity of density in the part leads to a more uniform shrinkage, which decreases the warpage on the part. And if that wasn't enough, the iMFLUX process eliminates the need for packing, so cycle time is cut down dramatically. Cycle time is reduced because of the continuous packing during filling. Pressure-controlled filling enables a lower pressure requirement. More even packing decreases average part weight and saves on material cost. And all this leads to a more even shrinkage distribution, making the part more dimensionally stable.